Hey everyone, Sal here. Welcome back to the channel. Today, we need to have a serious talk about a shared psychological trauma. It's that exact moment you stand in an Apple store or look at an online checkout cart, you see the grand total for a new MacBook, and you suddenly start questioning whether you really need two kidneys. We all know MacBooks carry a massive premium price tag. For the price of a mid-tier MacBook Pro, you could easily buy a high-end Windows gaming laptop, a decent monitor, a nice keyboard, a mouse, and probably a week's worth of groceries. So, why do millions of people, especially professionals, willingly pay the Apple tax year after year? Is it just brilliant marketing and a glowing logo? Or is there something fundamentally different happening under the aluminum hood? Today, I'm going to explain exactly what you are actually paying for, where MacBooks completely dominate the laptop industry, and the dark, frustrating issues that Apple definitely doesn't mention in their gorgeous commercials. Let's break it down. To understand the price, you first have to understand Apple's business model. Unlike Dell, HP, or Lenovo, Apple simply refuses to participate in the budget laptop market. They don't make a $300 plastic laptop with a flexi keyboard and a screen that looks like it was washed in milk. Apple starts their lineup at premium and goes up from there. You are paying for a chassis milled from a solid block of aluminum, custom-engineered acoustics, and some of the best displays in the world as a baseline. Let's talk about those displays. If you buy a premium MacBook Pro, you are getting what Apple calls a Liquid Retina XDR display. Beneath the fancy marketing speak, this is a high-density Mini-LED panel. While the Windows world has leaned heavily into OLED displays, which are fantastic for pitch-black contrast, Apple went the Mini-LED route for a very specific reason: blinding, sustained brightness. These MacBook screens can hit up to 1,000 nits of sustained brightness, and a ridiculous 1,600 nits of peak brightness for HDR content. If you've ever tried to work on a laptop outside at a coffee shop on a sunny day, you know most laptop screens turn into a sad, dark mirror. A MacBook Pro screen simply overpowers the sun. On top of that, every single MacBook screen comes perfectly factory calibrated out of the box. For graphic designers, photographers, and video editors, color accuracy is life or death. If your screen shows a shade of red that looks different on a client's monitor, you're in trouble. With a Mac, you open the lid, and it is instantly ready for color-critical work. There's no messing around with calibration tools or weird software profiles. Now, let's move our hands down to the trackpad. For over a decade, it has been an undisputed fact that Mac trackpads are the best in the business. But it's not just because the glass feels smooth. It's because of a brilliant piece of engineering called Force Touch. When you click a MacBook trackpad, you feel a satisfying, crisp click. But here is the mind-bending part. The trackpad did not physically move. It is a solid, completely stationary piece of glass. Beneath that glass sits a grid of pressure sensors and a highly precise electromotor called the Taptic engine. When you press down, the motor vibrates so perfectly that it completely tricks your brain into thinking you pushed a button. Because it doesn't rely on a physical hinge, you can click with the exact same effort at the very top edge as you can at the bottom. But a great piece of hardware is useless without software, and this is where macOS leaves Windows in the dust. Apple operates on a design philosophy called direct manipulation. When you use a three-finger swipe to change desktops or zoom in on an image, the software animation is glued one lens to your physical fingers. If you move your hand slowly, the animation moves slowly. If you stop halfway, the animation freezes halfway. You feel like you are physically shifting the digital interface. On a Windows laptop, even one with a high-end haptic trackpad, gestures usually act as triggers. You swipe, the operating system registers the command, and it plays a pre-recorded animation at its own speed. It feels slightly disconnected, like you're pulling a lever rather than touching the data. Furthermore, Apple forces third-party app developers to use their strict navigation rules. Whether you are scrolling in Apple's Safari browser or a completely random third-party app, the physics, momentum, and smooth rubber banding at the edge of the page feel identical. On Windows, scrolling through an old legacy application can feel like dragging your fingers across sandpaper. Of course, we can't talk about modern MacBooks without talking about Apple Silicon, the M-series system on a chip, or SoC. When Apple dumped Intel and started designing their own processors, they fundamentally changed how personal computers handle data. In a traditional Windows laptop, you have a CPU made by Intel or AMD, a graphics card made by NVIDIA, and separate sticks of RAM slotted into the motherboard. If your CPU needs to send a massive file to the graphics card to render a 3D image or edit a video, that data has to travel across a physical highway on the motherboard called the PCIe bus. It takes time, creates heat, and duplicates the data across different memory pools. Apple threw that playbook out the window. They put the CPU, the GPU, the AI neural engine, and the RAM onto a single, unified piece of silicon. This is called Unified Memory Architecture. Because the RAM sits directly on the processor package, both the CPU and GPU look at the exact same physical pool of memory. There is zero data copying. If a video file is loaded into the system memory, the graphics card instantly sees it and can work on it with zero transfer delay. This layout allows for absolutely massive memory bandwidth. While a typical Windows laptop might move data at 60 to 90 gigabytes per second, a high-end MacBook Pro can push data at over 400 gigabytes per second. The byproduct of this extreme integration is unparalleled power efficiency. MacBooks consume a fraction of the wattage that traditional Windows laptops require. This means a MacBook can run intensive software like compiling code or rendering 3D graphics while running entirely on battery power without dropping its performance or turning the laptop into a loud, screaming jet engine. You can easily get 15 to 20 hours of battery life out of a modern MacBook Air doing daily office work. A Windows laptop under a similar heavy workload will often start thermal throttling, spinning its fans at max speed, and dying within 2 to 3 hours. This combination of unified memory, high bandwidth, and hardware-level optimization is exactly why the MacBook is the absolute holy grail for professional video editors. And it all crystallizes around one legendary piece of software, Final Cut Pro. Final Cut Pro is what we call a killer app. There are thousands of content creators and Hollywood editors who buy a MacBook solely as a hardware container to run this specific program. Because Apple builds the hardware, the operating system, and Final Cut Pro, the level of optimization is almost supernatural. Final Cut Pro utilizes a unique structural system called the magnetic timeline. Instead of a traditional, rigid track system where you have to microscopically align clips with a mouse to avoid accidentally overwriting your audio or cutting another clip in half, Final Cut's timeline naturally flows, ripples, and snaps together. Because the software talks directly to the Apple Silicon media engines, you can smoothly scrub through multiple streams of raw 4K or 8K footage with zero dropped frames, entirely using the trackpad. You don't need a mouse. You can pinch to zoom, flick your fingers to fly down a 2-hour timeline, and make precision cuts using just your fingertips while sitting on a cramped airplane seat. Try doing that in Adobe Premiere Pro on a Windows laptop. Premiere is a highly capable, industry-standard program. But because it is designed to run on a million different hardware combinations, it cannot be perfectly optimized for a trackpad. If you try to edit a massive project in Premiere without a high-precision multi-button mouse with a physical scroll wheel, you will quickly find yourself pulling your hair out. Alright, so MacBooks sound like absolute magic, right? Well, hold on to your wallets, because it is time to look at the dark side. If you are a new buyer stepping into the Mac ecosystem for the first time, there are several systemic issues, design flaws, and predatory pricing structures that might come as a massive, unpleasant surprise. First, let's talk about the upgradability trap. When you buy a MacBook, the configuration you choose on day one is the exact configuration you are stuck with until the day that laptop dies. The RAM and the SSD storage are permanently soldered directly onto the main logic board. You cannot pop open the back panel and add a cheap 40 stick of RAM next year. And Apple knows this, which is why their upgrade pricing borders on extortion. If you want to upgrade a base MacBook from 8 GB of RAM to 16 GB at checkout, Apple will charge you an extra $200. In the open market, 8 GB of raw memory costs about $20. You are paying a massive markup simply because you have no other choice. Second, because modern MacBooks heavily rely on a feature called memory swap, where the system temporarily uses your ultra-fast SSD storage as extra RAM when you run out of physical memory. Buying a base model with low RAM can drastically shorten the lifespan of your computer. Constantly writing and rewriting data to an SSD wears out the physical drive cells. Since the SSD is soldered down, if the storage drive dies from heavy swap wear, the entire laptop becomes a useless aluminum brick. Furthermore, specifically during the M2 generation, Apple used a single physical storage chip on the baseline 256 GB models instead of two parallel ones. This cut the SSD speed completely in half compared to older models, making the system noticeably stutter when it ran out of RAM and tried to use that slower swap storage. While they quietly fixed this in later generations, it's a massive trap if you're buying used or refurbished hardware today. Next is a physical design vulnerability, the screen clearance trap. Apple engineers their laptops with incredibly razor-thin tolerances. When you close the lid of a MacBook, there is virtually zero space between the keyboard deck and the glass screen. Millions of users have permanently shattered their incredibly expensive Retina displays simply by installing a thin, plastic webcam privacy slider or a silicone keyboard cover. When you close the lid on those seemingly harmless accessories, it creates a localized pressure point that crushes the glass from the inside out. Speaking of hardware failures, let's talk about the speakers. MacBooks have the best audio in the industry, but they frequently suffer from a very specific failure point, the single-sided crackle. Over a few years of heavy use, users will suddenly notice a loud popping or scratching sound coming strictly from the left or right speaker. Because these micro speakers use powerful internal magnets to push massive sound out of a tiny space, they aggressively pull in microscopic dust, crumbs, or metal shavings from the air. Once that debris gets trapped inside the paper-thin speaker membrane, it constantly grinds against it during playback, completely ruining the audio and requiring an expensive, tedious hardware replacement. Finally, there is the bizarre external display limitation. If you buy a baseline MacBook with a standard M-series processor, the chip artificially limits you to connecting just one external monitor. Apple recently patched this on newer base chips so you can connect two monitors. But there is a ridiculous catch. You must physically close the laptop lid and completely disable the laptop's own screen to use those two monitors. If you want to use your laptop display and two external screens simultaneously, Apple forces you to step up to the much more expensive Pro or Max tier processors. So, what is the final verdict? Why are MacBooks so expensive? They are expensive because you are paying for an unparalleled level of hardware integration. You are paying for a display that can challenge the sun, a trackpad and operating system that move in perfect harmony with your hand, a processor architecture that defies the laws of battery consumption, and software optimization that makes creative workflows effortlessly smooth. But you are also paying for a gilded cage. You are paying for soldered components, forced upgrades, delicate design tolerances, and artificial hardware limitations designed to push you into spending more money. If you are a professional video editor, coder, or someone who values a seamless, long-lasting machine with zero configuration headache, the premium is absolutely worth it. But if you just want to browse the web, write documents, and watch movies, you need to think long and hard about whether you want to pay for all that heavy engineering. That's it for today's breakdown. Hopefully, this helps you make a much more informed choice before you hand over your hard-earned cash to the tech giants. If you enjoyed this deep dive, do me a huge favor and smash that like button, and subscribe to the channel so you never miss another straightforward tech explanation. This is Sal, signing off. Take care of yourselves, don't put covers on your MacBook keyboards, and I'll see you all in the next one.